And we have engine start. And
Allumage
liftoff.
UAP, décollage.
The James Webb Telescope continues to surprise the scientific community with its discoveries. The largest telescope in space is paying off every single penny of the $10 billion that were spent on it. High resolution and the sensitivity of the telescope allow scientists to view much farther than the Hubble telescope could ever see. Welcome to the Infinite Science, where we deep dive into space. The world was stunned at the details and resolution of the first ever images captured by the Webb telescope. But it did not stop just there and continues to make new discoveries one after another. Pictures of Stephan's Quintet, a group of 5 galaxies, images of the solar system, tracking of asteroids, and shots of the Southern Ring Nebula are a few of its noticeable revelations. The Webb telescope is also providing insights into the first few hundred million years after the Big Bang. What happened within that particular time frame remains largely a mystery until now, but it seems James Webb Telescope might have a few answers for us. Another one of its latest discoveries is Schrodinger's galaxy, which has baffled and confused the scientific community. Some believe that it defies the law of physics and has the potential to change everything that we know about the universe at this point. So how exactly did the Webb telescope discover this distant galaxy? What is about this galaxy that puzzles the scientists? And what could it mean for the universe? Stay with us to find out. To understand Schrodinger's galaxy, one has to understand that light has a finite speed. Whatever we see is because of light, and because it takes a certain time to reach our eyes, we essentially always see in the past. The phenomenon is not as noticeable on the Earth because everything is located at a close distance. But when we look at space, the speed of light plays a very significant role. To put things in perspective, it takes about 8 minutes for sunlight to reach the Earth. Hence, when we look at the Sun, we are essentially seeing 8 minutes in the past. Since the Moon is located closer to the Earth, the difference is minor at just 1.2 seconds. Now, use this example to understand that if a galaxy is 12 billion light-years away, it will take about 12 billion years to reach us. So when we look at that galaxy, we would look at the events that happened 12 billion years ago. Another important phenomenon to understand is the redshifting of wavelength because of the expansion of the universe. Our universe is expanding at a constant speed, and it is much faster than what we estimated. It is another one of Webb's discoveries, which would be discussed in a future video. For now, just understand that when the universe expands, it increases the wavelength of light that reaches us. And this phenomenon is known as redshifted. Scientists use Z, a dimensionless quantity, to represent redshift. Z equals 0 indicates that we are looking in the present, but when it increases, we begin to look back in time. The larger the Z value, the farthest we can see in the past. We have been able to discover just one galaxy beyond the Z10 era of the universe, named GNZ11, which was found by the Hubble telescope in 2015. It is the farthest and the largest telescope at that time could ever see, but it changed with the invention of the Webb telescope. The new telescope has provided us with a view of Z greater than 13 with much more detail and clarity. Astronomers have discovered several galaxies within the Z13 to 14, and it is quite exciting. But things were taken to a whole another level when some researchers discovered a galaxy in Z17, which was named CER as 1749. Scientists estimate that it is the view of the first 220 million years right after the Big Bang. Hence, essentially, we are looking at the dawn of time. The first piece of the puzzle is the actual location of CER 1749. Scientists believe that there could be 2 potential locations of this galaxy, and the exact location cannot be determined with accuracy without additional data. Rowan Naidu, an astronomer at Harvard University, pointed out this galaxy in a paper that is yet to be peer-reviewed. The brightness of the CER 1749 is the source of confusion for all scientists right now. Typically, galaxies as luminous as this are located within Z5 to 6. But there is an explanation for its brightness even in the Z17 as well. The light waves emitted by distant galaxies and planets are stretched over time. and it is very normal for waves to move towards the red of the spectrum, which makes the object more luminous. Now, because this particular galaxy is located too far away from Earth, the UV lights emitted from this galaxy would move towards infrared, which is brighter, and it is exactly what Webb's telescope is designed to capture. If the CER 1749 is verified to be located in the Z17, it could change the standard assumptions of the ACDM cosmology and the models that are used to reproduce the formation of the universe. If CER 1749 is confirmed to lie at C equals 17, it would force a major revision of early galaxy evolution models and potentially even our underlying cosmological framework. It is very challenging to produce such extraordinarily luminous and massive galaxies, only at 220 million years after the Big Bang, understand assumptions in the framework of ACDM cosmology. Schrödinger's principle of uncertainty has unparalleled importance in the world of cosmology. It states that we cannot know both the position and the speed of a particle, such as a photon or an electron, with perfect accuracy at the same time. If this principle is applied to the case of CER 1749, it shows that there is a non-zero probability that the galaxy lies in the Z equals 5 region. Although the observations strongly suggest that it is located in the Z equals 17, there are some clues that point in another direction. The surrounding galaxies of 1749 lie within the range of Z 4.8 to 5.3, and one neighbor of the CER 1749 has a stellar mass of 100 billion solar masses. Hence, it is possible that 1749 is an associate of this massive galaxy and is actually located within the Z equals 5. The morphology of this distant galaxy also supports the Z equals 5 solutions. Researchers have pointed out the possibility of this galaxy being a clumpy disk or a merging pair. It is because 1749 lies in a dense photocluster environment. It is also possible that the galaxy is in the process of tidal disruption from its neighbor, provided that they lie in the same redshift. The CER 1749 is either located in the Z equals 5 or in the Z equals 17, but either way, it challenges the existing laws of cosmology and physics. If the galaxy is confirmed to lie at C equals 17, it would force a revision of the model of the early evolution of the universe. It is a big deal because a lot of the cosmological principles and laws of physics are derived from these models. But even if it is located in the Z equals 5, it would force several changes in the law of cosmology. And it is because of the star formation rate in this particular galaxy. The current laws of cosmology suggest that such a galaxy would have a star formation rate of just 0.1 solar masses per year. However, researchers have found that the star formation rate of this galaxy is about 34 solar masses per year. The difference between the two values is quite significant, and it could break the cosmology models as we know them. The paper has made astonishing discoveries that could force major changes in the cosmology models and the law of physics. But we have to be mindful that the publication has not been peer-reviewed yet. It will be screened by several scientists, and the location of the CER 1749 would be cross-checked by them as well. But if no errors are found within the publications, the scientific community, especially the cosmologists, are in for a roller coaster ride. The implications of this discovery are huge and could force the revamping of the cosmological model. For now, we would have to watch how the scientific community reacts to the discovery. Stay connected with us to learn more updates on this topic and the other discoveries of the James Webb Telescope. We will see you in the next one.